Consider the sequence of numbers A0, A1, A2, and so on, given by the following. So A0 is 0, A1 is 1, and AN is equal to AN minus 1 minus 2 times AN minus 2, whenever N is at least 2. So A2 is going to be 1 minus 0, so that's again 1. A3 is going to be 1 minus 2 times 1, so that's minus 1. And if you work out the first 10 terms of this sequence, you'll get this list. Now the question is, what is A100? Surely we can use this recursive formula to obtain the value for A100. Wouldn't it be nice if we can have a formula that directly gives us the value of AK? And we're going to work towards this. So what we're going to do is we're going to let xn to denote the tuple an minus 1. And let A be this matrix 1 minus 2, 1, 0. Now what happens if you take a times xn? Well, you'll get an minus 2, an minus 1 in the first entry, and just an in the second entry. And if you look at this first entry here and compare with this, you will see that the first entry gives us an plus 1 and an here, and this is just xn plus 1. What that means is xk is going to be a to the k minus 1 times x1, and this is true for k at least 1. And we know that x1 is 1, 0. So all we need to do is compute a to the k minus 1. And now this is a power of a matrix, and if we could diagonalize a, computing this will be quite simple. So the goal is to diagonalize a, and you can in fact write a as p times d times p inverse, where d is this matrix and P is this matrix. So with this, we can write down xn plus 1 to be a to the n times x1, and that's just p d to the n p inverse times 1, 0. And this, if you work it out, will be this tuple here. But since xn plus 1 is an plus 1 and an, so an is this, and this formula is valid for all n at least 1. So we have expressed an in closed form, and all you need to do is, in order to calculate A100, just put 100 for n here, and you'll get the answer. An interesting thing here is that this expression involves complex numbers, but as you can see in our definition for the sequence of numbers, everything is actually an integer. So I hope that this example shows that not only complex numbers are useful, they seem to be quite natural.